All right, looks like we're up and running. Day 3 should be garnering some understanding if you're doing these on a daily basis, and you're getting the reps you need for hopefully keeping this a little bit in your longer term memory. As you move up the ladder in math, it's only what you remember that allows you to continue moving up the ladder. Because the things that we're looking at, foundational. All right, so I did put in the sign changes. They're all odd exponents, so we're going to get sign changes everywhere. You can pause the video and look at that to make sure you understand that sign change process. All right, so a positive times a positive times a positive. I put a big number in here. It's true. I am bigger than 0. So this is what the graph's going to look like. We have a cubic root, so it takes on that cubic look. Linear root right there. Close enough. What am I bigger than 0? True, false, true, false. And we can see that in the sign multiplications. We have a positive answer there. This one becomes negative. This one becomes positive again. This one becomes negative. We can see that play out. So -4 to 0. Union 9 to infinity. Hopefully you get a little better at that. Okay. 1 period of the cosine function. Let's see. All right, I guess that'll work. So max to max is 1 revolution, and max occurs at 0 degrees and 360. In radius lengths, that's 0 and 2 pi. And that's what we're going to work with. So here, pi x, what's in the parentheses, could equal 0. When x is 0, that happens. That gets us 11. Our midpoint is 3, right? That's the midline. And when we come back to it, which is 2 pi, pi over x equals 2 pi. Well, that happens when x is 2, and I think we can see that pretty clearly from here. That gets us 11. And so if that's 11, then we've gone up 8, so we got to go down 8 to -5. And it looks like if you put a 1 in, that 1 pi over here gets us -1 for a width. Remember, these are triangles. No height at that location, but width's -1. And so we're going to end up with -5. Righty. Oh, the other thing I wanted to say about this, we've been talking about recently the multiplication by x, in this case is pi. If you take that multiplier and you divide it into 2 pi, you're going to get your period. And we can see what it is from 0 to 2. So let's do it. 2 pi divided by the multiplier pi. Oh yes, that divides to be 1. 2 units. You might apply that over here. Why don't we apply it now? Take a little shortcut. All right, so 4x minus 8, the multiplier is 4. If I divide that into 2 pi, I get pi over 2. We're roughly 1.57 units from start to finish. All right, so sine, midline, 7. Going up how much? 50. 57. Going down 50. Oh, down 50. -43. Okay, where are we going to start? When 4x minus 8 equals 0, and that's at 2. And therefore over here, 2 plus pi over 2. That's a little shortcut. Just dividing 2 pi by 4 gets us a height of 7. That's 7 over there. Okay, so we got our range, -43 to 57. Up and down, so on and so forth. So that takes care of that one. And so we have pi over 4, 2 plus pi over 4 here, 2 plus pi over 8. Then you can put some of these inputs to see what you get. I suggest you do that, build some skill. All right, we're looking at domain. Well, let's look at the critical numbers. I can't use 4. This has to be positive. 4 minus x has to be positive. 4 minus x can't equal 1. So 3. 3 is not a nice number because ln of 1 is 0. Then we cannot divide by 0. X -2 is okay, but I can't put anything less than -2 because I get a square root of a negative, and that's not going to show up on the Cartesian coordinate system. So what do we have? We've got -2 to 3, union 3 to 4. Okay, moving at a pretty quick pace here. You can always pause the video, give each problem more time, give yourself more time, and then you can just check to see what kind of mistakes you made. Hopefully none. Hopefully I can get through this without making any mistakes. -6 over -9, 2/3, y-intercept. See that? Nah, I'm not sure about that. Well, yes, I am. I can put a 0 in, so I am sure. But gotta be careful here. So x -3 times x plus 2 divided by x -3 times x plus 3. So we have a point of discontinuity at 3 something. Oh, we can put it in now. 5, 6. So 3 gets me 5, 6. 5, 6 is, yeah, bigger than 2/3. This brain's slowing down here. All right, so I'm going to put a little open circle there, and I'm going to label it. My end behavior is going to be 1, so it's going to be above it. So I think I can put it here. What did I say it was? 5, 6. 5 over 6 when x is 3. That's not very well. Okay, point of discontinuity right there. When x is 3, the y value would be 5, 6, but can't use the number 3. -3, asymptotic behavior over here, -3. -3. See all this? I really do such a good job of putting the screen where it belongs. That's better. All right, and we can see that x squared divided by x squared are the major players. When we put huge numbers in, we can forget this other stuff. So put a huge number, then 2 numbers are only 1 apart. You can see that, these are the same, basically the same number. So it's going to 1 on the right, and it's going to go to 1 on the left. Any x-intercepts? Yeah, 1 at -2. So it goes through at -2. Okay, I can see this clearly now. And no more x-intercepts, so it's got to do that. And so 2, 0, -2, 0, x-intercept. We got our y-intercept at 0, 2/3. We labeled the asymptotes. I guess we're in good shape. What am I less than 0? Just this little segment right here from -3. So my x values, I guess over here, you can see this. X has to be what? Less than -2, but greater than -3. That's when I'm getting negative y values. Domain, a little trickier. -infinity to actually a height of, to 3. So wait a minute, I gotta be careful. -infinity, I'm doing domain, I was doing range for a second. -infinity to -3, union, -3 to 3. I can't use 3, but I can go from 3 to infinity. And these are the numbers that I can plug in to this equation and get some y values out. What would the range be? I guess I could write it here. The range is -infinity to a height of, I guess, 5, 6 by the look of it. 5, 6 really doesn't exist. Does it exist over here? No. So 5, 6, union, 5, 6 to 1. That's a little tricky. I can't get the number 1 because these are always 1 unit apart. Get them close, but, and then union 1 to it. Well, they got a little trickier there. A little point of discontinuity, which affects domain and range. And I labeled the point of discontinuity. All right, that's done. Oh, I left the words. Be careful up there from the last video. This one, I don't think you have to be too careful. I think it's pretty straightforward. So let's see if you can fly through it. X equals 2. It's going to 0. Cannot. There's no way you can make that fraction equal 0, so there are no x-intercepts. Y-intercept -2.5, and it goes to 0 as well. So Should label the asymptote over here, y equals 0. Same thing really over here, y equals 0. As x's get bigger, put 100 in there. 5 over 98. I hope you can tell that if you put 1,000 in, you get 5 over 998. Okay. That's closer to 0 than the other function. All right. So what's the limit? Talk about limits in a while. What's the limit as x goes to 2? You've been watching all the videos, g of x. Then you'll know that it does not exist. Because as I come in from the left, -10, -9, -8, 7, 6, 5, 4, 3, 2, 1, 0, 1, 1.9999999. I'm heading to negative infinity. But over on this side, 10, 9, 8, 7, 6, 5, 4, 3, 3, 2.5, 2.1, 2.11111, 2.001, heading to positive infinity. I don't know where I'm going, so it doesn't exist. If I was coming in from the right, yeah, going to infinity. Tell you where I'm headed. But you're making me choose. I don't want to choose. Makes me feel awful. Do I want to choose positive numbers or negative numbers on any given day? All right. -4, -5. It's good to get a frame of reference. So let's throw 0 in here. -12, -5, -17. 0, -17. And I'm eventually going to be looking at heights of -47, which is way down here. I'm trying to find that point of intersection and that point of intersection. How do we do it? Well, let's write it as a piecewise first. Let's get Alfred Hitchcock up on the board. All right, so going up on the right. All right, well, that's a linear function, 3 times x plus 4 minus 5. But we're only doing that for x values. Once they get past -4, so less than -4, I'm doing that. Then I'm going down. -3, x plus 4 minus 5. But that happens when x's are greater than or equal to -4. Excuse me. All right, we can use the pieces now. Let's do 3 times x plus 4 minus 5. Let's set it to -4. Add 5, -1. Oh, I got some fractions here. Did I want fractions? Oh, I wanted 47. That's mine. I'm solving this for 47. Got my 4's mixed. I don't want to hit you with fractions. -5, add 5, so -42. Divide by 3, -14. Subtract 4, -18. All right, -18. So that's this x value here. Okay, and -4, so that's 14 units. So 14 units from -4 should get me 10. This one should be 10. But let's make sure to show you that that shortcut can be done. We got to do a negative this time. So we're back to -42, but that makes this positive 14. And we take 4 away. Yes, it was indeed 10. And so when am I less than? I wanted less than 47. That's here and here. Right? That's those x values. So I think we can see from here. I don't have to do anything else. I can just say -infinity to -18. Union 10. Did I say equals? Yes, so I got to do a bracket here. Bracket 10 to infinity. All right, good enough. Name that tune. I think it's easier to do maxes with the sine function, and then we'll convert it to the cosine function. Can you see everything? Yes, you can. All right, so I can see that the midline here, I got to get the midline 16 to 30. 36 cut in half is 18 amplitude, is that right? 46 cut in half, excuse me. 23. Yeah, that works. So y equals 23 plus what, 7 sine pi, half a revolution, took 99 years. X minus 1500 plus pi over 2. Yeah, that takes care of that one. So we could also do 23 plus 7 cosine pi over 99 x minus 1500. And that's done. And now you might start to see a pattern. These are the same function. They create the same graph. So what's the difference? Oh, looks like the sine and cosine are 90 degrees apart. I want to think about that one a little bit. All right, we'll talk more about that in class. I think we'll do the rule of logs first this time. And this is here to, just remind people some simple values. E to the negative 1.1 is approximately a third, which means that e to the 1.1 is 3. We've talked about that. Negative exponents reciprocate bases. All right, so let's do the rule of logs first. I see 5/8, so division implies subtraction of exponents. Ln of 5 minus ln of 2 cubed. Power to power implies multiplication of a different sort. Ln of 5 minus 3 ln of 2. Now we convert that to 1.6 minus 3 times 0.7, and that's 1.6 minus 2.1, which is negative 0.5. All right. So negative 0.5, really? 0.5 is a half, which means I'm taking a square root of e. Interesting. Well, let's do it organically. So 5/8, and then you can see if you can spot what's going on here based on what's happening over here. And I think you can see it all. Yes, you can. So 5 is e to the 1.6 on a calculator, pretty darn close. 2 is e to the 0.7, e to the 0.69, oh something or whatever, it's a little closer, but we'll use that. It's close enough for us. And we are doing what to 2? We're cubing. All right, can you see 3 times 0.7, which is, can you see subtraction? Can you see e to the 1.6 minus 3 times 0.7? That's what you're trying to see. And the ln is simply about the exponents on top of e. So what's 1.6? The ln of 5. What is 3 times 0.7? 3 times the ln of 2. Okay, so hopefully, as we keep doing those, some of those rules will start to make some sense. We'll give you plenty of time to try to process that. And I just don't think doing it 3 days in a row gets the job done. All right, what am I looking at here? I'm looking at the board is good shape. All right, so we want x minus 10. So argument, the parentheses to equal 0. We want it to equal 1. We want it to equal the base, which is 1/3. I know I'm going to do that one second. All right, so 11. No, 10, excuse me, 10 is a border. That makes a 0, and that's undefined. You cannot find an exponent. You can try. You go ahead, you try to find something that gets you 0. Not going to happen. So let's do 1/3. Let's put 10 and 1/3 in. That gets me 1/3. So what is 5 log 1/3 to get 1/3 plus 7? Well, I hope you see when these are the same, you get 5 plus 7. Keep an eye out for that. You'll get these done faster. 10 and 1/3, pretty darn close to 10. So let's do 10 and 1/3 gets me 5 plus 7 is 12. I know exponential decay, the inverse looks like that. And so what makes 1? 11. And that gets me log 1/3 to get 1. Well, 1/3 to the what equals 1? I hope you're saying 0. And if you're saying 0, 0 times anything is 0. You're going to get that number each and every time. That should be smaller than that, and it is. And we can certainly put numbers in like 10 and a 9th and 10 and 1/27th. And I got a feeling we're going to be jumping by 5 each time, but you go ahead and check that out. All right, 23 pi over 4. So we're going to break this up into 4 parts. Good drawings get good answers. 45-degree triangles. I know where 24 pi over 4 is. That's 6 pi. Well, that's 2 pi, 2 pi, 2 pi. Yeah, I want to go to 24, so I'm right, 23, excuse me, I'm below that. Thought it was 25, so I am gonna have to do that. There we go. And I'm looking for the cosine, which is root 2 over 2 divided by 1. I don't have to divide by 1, it's root 2 over 2. And I hope you know what that is as a decimal, and if you don't, I'll help you. I'll remind you, 0.71. And if you square 0.71, you're getting a little bit bigger than 0.49. And that's pretty darn close to a half, which means the Pythagorean relationship is alive and well. There's a half. There's a half. Right? And a half adds up to 1. Oh, God almighty. Oh, that kind of looks like the cosine squared x plus the sine squared x equals 1 squared, which is 1. I wonder if that happens all the time. Keep an eye out for that. All right, that's that one. Day 3, coming your way to a theater near you.